Okay, so in this video we're going to look at the laws of indices. And the first thing I'm going to do is I'm going to go to where these are listed out in your log tables, okay? So if you go to indices and logarithms on page 21, we can see here down on the left hand side the list of the laws of indices, okay? So I'm going to refer to them as they are in your log tables because this is what you're going to have with you in the exam, okay? So there are 9 altogether. All right, now depending on your level, you don't need to be aware of all 9. I'm going to go through them as in the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, so you'll know which one I'm referring to from the list in the log tables. Okay, so looking at the first one is written as 8 to the power of p, 8 to the power of q equals 8 to the power of p plus q. Now that's the way it's written. And what this means, because these two are side by side like this, it means they are multiplied, okay? So this can be a little bit harder to maybe understand. So what I'm going to do is I'm going to explain each of these laws using lots of examples so you fully understand what exactly it is saying with each of these laws that are written in the log tables. Okay, so what this is saying is, let's take an example. If you had x squared, okay, and you are multiplying by x cubed, then you can simplify that to x to the power of 2 plus 3. You can add the powers. If you're multiplying the two terms and both terms are a power of x, okay, so you have x to the power of something times x to the power of something, then what you can do is you can add the powers, okay? So what we should be getting is x to the power of 5. Well, let's have a look in more detail and see if that is true. X squared, of course, is the same as x times x, isn't it? And x cubed is the same as x times x times x. Yeah? So if we were to multiply these by these, we have x times x times x times x times x. And if you have 5 x's all being multiplied to each other, then yes, we can write it as x to the power of 5. All right. So another little look would be, let's to do with numbers. If you had 2 to the power of 4 times 2 to the power of 7, if we wanted to write that as a power of 2, if you wanted to simplify it, we could write it as 2 to the power of 4 plus 7. So 2 to the power of 11. Okay? And obviously you can go ahead and evaluate 2 to the power of 11, but often in the question you just want to simplify the powers. Now, one key thing to point out here is it has to be the same number that's being raised, okay? For any of these laws of indices to work, you have to have the same number being raised. That's why in the law that's in the log tables, it has quite clearly an a to a power times an a to a power will give you a to the 2 powers added, okay? You couldn't have, for example, 2 to the power of 4 times 5 to the power of 7, okay? That won't work, all right? Because it's not the same number that's being raised. It has to be 2 to a power times 2 to another power, and if they are both powers of 2 and you're multiplying, then you can add the powers, okay? So that's the key thing. When it's multiplication, we can add the powers. And that's how we can simplify it. Okay, the second law as it appears in your list on page 21 of your log tables is written like this. When you have a to the power of p divided by, so you've got a division sign here, a to the power of q, it is the same as a to the power of p minus q. Okay, so again, let's take a look because this can often be a little bit complicated. Let's take it in 2 examples so we can see a little bit clearer exactly what's going on. Let's say we have x to the power of 5 and we're dividing by x to the power of 3. Okay, what this law says, it's the same as x to the power of 5 take away 3, which says it's the same as x to the power of 2. Well, let's see if that's true. x to the power of 5 is, of course, x times x times x times x times x. X multiplied by itself 5 times. And then if we're dividing by x cubed, that's the same as x times x times x. Then what have we got? Well, we have that x will divide into that x once, that x will divide into that x once, and that x will divide into that x once, and leave me, of course, with just an x times x. And of course, x times x is x squared. So that is how we are getting it. So in other words, when you are dividing with powers, when you have both of them being raised, you see the same thing is being raised. You have an x being raised here and an x being raised here. So that's how this law works. This is how we can simplify it. Well, if you're dividing, then what you can do is you can subtract the powers. Okay, let's take a numerical example of this. So let's take 2 to the power of 6 divided by 2 to the power of 2. Okay, and 2 to the power of 6 divided by 2 to the power of 2 is the same as 2 to the power of 6 minus 2, which of course is 2 to the power of 4. Okay, so when it's division, you subtract the powers. That's what the second law of indices says. Okay, the third law of indices, as it appears in your list on page 21, has that if you have a to the power of p, and then that's all being raised to the power of q, it is equal to a to the pq. Now, pq, when it's written like that, means, of course, p times q. Okay, so that's another way of writing that. That's the way it appears in your log tables, but remember, pq written beside each other always implies times. So now let's take a look at this again in a clear example. Let's say you have x squared all to the power of 3. So x squared all raised to the power of 3. Now what this law is saying is that's going to be equal to x to the 2 times 3. And 2 times 3, of course, is 6, so it's equivalent to x to the power of 6. Well, let's see, shall we? X squared, another way of writing x squared is x times x. Now, if you're cubing that, that means you're multiplying that by itself 3 times. So you'll have x by x times itself once, x by x again twice, and times x by x again 3 times. You have x squared multiplied by itself 3 times. And of course, what are you left with? X times x times x times x times x times x, which of course is x multiplied by itself 6 times, which is x to the power of 6. So that's where that's coming from. So what the law is saying is when you have a power to a power, you multiply the powers. Okay, so in other words then, a nice numerical example might be 2 to the power of 4 all to the power of 5 would be the same as 2 to the power of 4 times 5, which is 2 to the power of 20. Okay, the fourth law, as it appears in your log tables on page 21, says that a to the power of 0 equals 1. Now, what this basically means that anything to the power of 0 will always equal 1. Okay, well, let's take a look at a way of explaining this. How does this work out to be true? Anything raised to the power of 0 will always be 1. That's what this law is saying. Well, let's say we have x to the power of 0, and what this law is saying is that's going to equal 1. Well, let's see how can we make that so that it explains how we are getting 1. Well, another way, I suppose, of getting x to the power of 0 would be to consider the following example. If you had x squared divide by x squared by our second law of indices, if you have division, you can subtract the powers. So you'd have 2 minus 2. And of course, 2 minus 2 is 0. Okay, so another way of considering x to the power of 0 is to consider the example x squared divided by x squared. Because it is true, if you have x squared divided by x squared, you can subtract the powers and you'd get x0. So they are equivalent. Okay, now x squared divided by x squared. Well, that's the same as x times x divided by x times x. And of course, x goes into x once and x goes into that x once. So the whole thing divides into itself once. And of course, that means we are left with 1. So x to the power of 0 is equal to 1. All right, let's do another example of that because sometimes that one can be a little bit hard to get our heads around. Let's do a numerical example, might be easier. Let's say we have 2 cubed divided by 2 cubed. Okay, and as we said, the law of indices says that we can subtract the powers, so we get 2 to the power of 3 minus 3, which is 2 to the power of 0. And of course, the other law of indices says that 2 to the power of 0 is equal to 1. Well, let's see, working it out numerically, 2 to the power of 3 is 2 times 2 times 2. Divide by 2 to the power of 3 is 2 times 2 times 2. Okay, and of course, that works out to be 8 divided by 8. And 8 divided by 8 is, of course, 1, which means that 2 to the power of 0 is 1. So, in a nutshell, all you have to remember with this fourth law is that if you ever have a power of 0, the result will always be 1, no matter what number or what letter or whatever is in there. If it's being raised to the power of 0, you will always get 1. Okay, so the fifth law says that if you have something being raised to a negative power, then it is equivalent to 1 over that something to that power. Okay? So the way I always like to look at this is you have to link up the fact that that minus always stands for 1 over. Okay? And then whatever else you have, so for example, whatever is here to whatever is here, that power, that goes underneath. Okay? So let's take a look here. If we have x to the power of minus 3, okay, what is that going to be equivalent to? So straight away, the power is a minus. So the first thing I'm going to do is 1 over, okay? 1 over always has to be written if you've got a minus. And then what's left? Well, we have x to the power of 3. And so that's what I need to write now underneath here, x to the power of 3. Do you see the way you're always going to look at that? So if you have a minus, it's always going to be equivalent to 1 over. Let's take another example. Let's say you have 2 to the power of minus 4. Well, 2 to the power of minus 4 is equal to, and again, the minute you spot you've got your minus, immediately put down your 1 over. That's always what the minus stands for. And then what's left? I have 2 to the power of 4. So I'm going to put 2 to the power of 4 underneath that line. Okay, and 2 to the power of 4. If you are to evaluate further, sometimes you just want to keep it written as a power. Depends what the question asks. If you were to evaluate further, you could evaluate what 2 to the power of 4 is. And of course, you could do that on your calculator. So 2 to the power of 4, I'd put in 2. And then if I want to put in a power, that's something other than a squared or a cubed, I can put in the box, and then I can put in the 4. So there's 2 to the power of 4 is, of course, 16. So it's the equivalent to 1 over 16 is 2 to the power minus 4 fully evaluated. Okay, the 6th law of indices that's written here in the log tables is explaining that if you have something being raised to a fraction, okay, so when the power is a fraction, then it's always equivalent to the root of a. Now, depending on what the denominator is, that tells you what root to take. So let's jump straight into an example here. Let's say you have x to the power of a half, okay? So straight away you spot that you've got a fraction. Immediately in your head you should be remembering that it's going to be a root. And because it's a 2 on the denominator, that means it's going to be the square root of a. Okay, that's the way we describe that. Now, the thing with square root is we don't tend to write the 2 for square root. We always just tend to write it as root a, okay? We don't tend to put the 2 there, okay? However, the minute that denominator becomes anything other than 2, we do put the root in, okay? It makes a huge difference. Let's jump straight to a numerical example here so we can kind of see and evaluate exactly what's going on. Let's say you have 4 to the power of a half and we want to fully evaluate this, okay? We'll first write it as a power and then we'll fully evaluate it. So immediately, as we said, we've got a fraction, so we know it's got to be a root. The 2 as a denominator, which means it's going to be the square root of 4, okay? And again, we don't usually write square root with the 2. We just tend to write a square root of 4 like that. Square root of 4, of course, is 2. So the answer to 4 to the power of a half is 2. And you can always check that on the calculator. Look, 4 to the power, and then in the power we're going to put the fraction 1 over 2, and it is, of course, 2. And that's because a power of a half is always a square root. Now that's really important to remember. All right, a power of a half is always equal to the square root. That is a really common one that comes up, the power of a half, okay? And it's one that pupils usually do trip up on. So really learn that one off. Any power of a half is always equal to a square root. Now, what if the power is not a half? So let's have a look at that, okay? So let's say you have x to the power of 1 over 3. Well, what this is going to be, right, following our law from up here, okay, the minute you see it's a fraction, we know it's going to be a root, and this denominator here tells me what kind of root it's going to be, okay? So x to the power of a third is going to be equivalent to the cubed root of x. Okay, so that's another way of writing it, the cubed root of x. Again, now we do, obviously with the cubed root, we have to keep the 3 in there, okay? It's unlike the square root. Square root, we tend to just write as the squared sign. We don't usually put the 2 in there, but for cubed root, you have to have the 3. And any other number that's the denominator, you will have to include. So let's do a numerical example. Let's say we have 8 to the power of a third. Well, that's going to be equivalent to the cubed root of 8, okay? Because whatever's on the denominator of the fraction is telling you what type of root it is. So the cubed root of 8, and again, if I have to evaluate that on the calculator, what I would do is, I'm going to do this both ways. I'm going to do it as 8 to the power of a third, and then I'm going to do it as cubed root 8. So 8 to the power of, and I'll put in the fraction 1 over 3. So the result I'm getting is 2. So the cubed root of 8 is 2. And now let's check if I put it in as cubed root. So the way I'm going to put in cubed root, it is above the square root button, if you can see. So I'm going to press shift, and then that gets it up. Cubed root of 8 is, of course, 2. And the reason it's 2 is because what the cubed root of 8 is asking you is what number multiplied by itself 3 times will give you 8. And of course the answer is 2, because 2 times 2 times 2 is 8. The square root, of course, the square root is always asking you what number times by itself is giving you 4. In other words, what number times by itself twice is giving you 4. And the reason that is an answer of 2 is because 2 times itself is 4. 2 times 2, when there's 2 of them, it's 4. Okay? When there's 3 of them, 2 times 2 times 2, that's where we're getting 8. So the cubed root of 8 is 2, because 2 times itself 3 times gives you 8. Okay, so that law, again, in a nutshell, is, we'll give one more example here. Let's say you have a 16th power of a quarter. The minute you have a fraction, it's going to be a root, and the denominator tells you what root it's going to be. So if it's a power of a quarter, then it's the same as the 4th root of 16. And the 4th root of 16 is asking what number times by itself 4 times will give you 16. And the answer is 2, because 2 times 2 times 2 times 2 is 16. Okay, and again, you can put it like that on the calculator, 4th root of 16, or you can put it like that on the calculator, 16 to the power of a quarter. So the key thing to remember here with this law, although it's quite tricky, is just the minute you see a fraction, it's going to be a root. Okay, the 7th law, as it's written in your log tables on page 21, the 7th one that they have is this. Now, this one is by far the most complicated. It does follow on from the 6th law. So let's just revisit the one before again, okay? So, quick little recap. The 6th law, as it's written in the log tables, is a to the power of 1 over q is equal to q root a. Okay, and what I was saying to you in that one is the minute you've got a fraction, the denominator tells you what root it is. Now, we still have a fraction with this one in the 7th law, but what's different is in the first one we had 1 over, okay, so it was just the denominator we had to worry about. All right, here we have a numerator as well as a denominator, okay, and of course that will have an effect. All right, let's jump straight into a numerical example for this one. So let's say you have 16 to the power of 3 over 2. Okay, so that kind of a fraction. So another way to look at 16 to the power of 3 over 2 is to consider it as 16 to the power of a half all to be cubed. Because, of course, a power to a power, if you remember our 3rd law, which states that a power to a power, all you have to do is multiply the powers. Of course, 3 over 2 is the same as 3 times a half, or a half times 3, isn't it? So that is equivalent to that. Writing it as 16 to the power of 3 over 2 is the very same as 16 to the power of a half all to the power of 3, because a half times 3 is, of course, 3 over 2. And that is always how you would simplify a power to a power, remembering our 3rd law of indices. Now, 16 to the power of a half then, well, remember from our last law, I said the minute you have a fraction, we know it's going to be a root, okay? And we were always dealing with the 1 over, those kind of fractions in that 6th law. So 16 to the power of a half then would mean that it would be the square root of 16 is another way of writing 16 to the power of a half. And of course, we need to cube that. And so the square root of 16 is working out to be 4. And now we'll do 4 cubed. And of course, 4 cubed is 4 times 4 times 4, which is 64. Okay, so 16 to the power of 3 over 2 is 64. Let's have a look at that on the calculator. So 16 to the power, we'll put in the fraction, 3 over 2 is equivalent to 64. Okay, so that's kind of a little bit of an understanding as to what we're dealing with here when we have a numerator and a denominator. So let's just analyze it a bit further. Key thing is your denominator always tells you what root it is, okay? Your numerator is always going to be then to the power. Now, whether you're considering it over here, like I did, I kept it out on the brackets, or whether you're considering it in the root. Either way, it doesn't matter. So that numerator, that number on the top of the fraction, you're always going to raise the whole thing to that power, okay? So whether you raise it to the power before you root it, or whether you do the square root and then raise it to the power, either way you're going to get the same answer. And I'm going to show you that in the two ways. So I did it this way, okay, so that you could see very clearly how I was breaking apart the fraction to show you how I was getting every single bit, all right? So I was kind of following this way. I could also do it this way, and I'm going to do that now to show you that they're all still equivalent. So 16 to the power of 3 over 2 is the same as, the denominator always tells you the root, so the square root. But I could do this 16 to the power of 3 inside the root, rather than keeping it outside until the end, okay? The order would still work out to give you the same answer, whether you do it at the end to the power of 3 or whether you cubed before the root. You will still get the same result, 64. So let's just show you why. This turns out to be a very, very large number. That's why it's actually easier to do the root sometimes first before the cubing. So in this case, if you were to leave the root till the end and you're doing the 16 to the power of 3, 16 to the power of 3 works out to be 4096, and then of course square root 4096 is 64. Okay, so they're both the same, and that's why you get two different versions of this law for the seventh law. All right, either way, here's the key thing. When you've got a fraction, you've always got a root. The denominator tells you which type of root it is, and what's on the top is always going to be the power that the whole thing is being raised to. Okay, so let's take another example to see this at play. Let's say we have 4 to the power of 3 over 2. Well, the minute you've got a fraction, you know you've got a root straight away, okay? And the denominator tells you what type of root, and then it's 4, and of course the numerator tells you the power, okay? So you can write it like that, or you can write it as the square root of 4 all to the power of 3. So the power can be in the root or outside the root, okay? Whichever way is going to work out easier for you. I'm going to do it both ways so you can see that they're equivalent. So if I was doing 4 cubed first, so I'd have the square root. 4 cubed, of course, is 4 times 4 times 4, which works out to be 64. And then, of course, the square root of 64 is 8, because 8 times 8 is 64. So if I'm doing it this way around, of course, and I was square rooting first, I would get 2, square root of 4 is 2, because 2 times 2 is 4, and then cube it. 2 cubed is of course 8, because 2 times 2 times 2 is 8. Okay, the last two laws that are written in the order, the 8th and 9th, in your log tables on page 21 are these two. Now these two are quite straightforward actually. All these are saying is if you have two things multiplied and the whole thing is being raised to the power, then it's the same as the two of them each being raised to the power and being multiplied. And in this one, if you have two things that are being divided and all being raised to a power, then it's the same as each of them being raised to a power and divided. Let's take a look at it straight away in clear examples. So let's say you have x times y all to the power of 2. Then what this law is saying is it's the same as x to the power of 2 times y to the power of 2. Okay? So another numerical type example, let's say you have 3x all to be squared. Well, it's the same as 3 squared times x squared, which of course is 9x squared. You must square both terms. In other words, if the whole thing is being raised to the power of 2, then each of them has to be raised to the power of 2 and multiplied. Okay, and in this one, it's saying that if you have x divided by y all to the power of 2, then it's the same as x squared divided by y squared. Okay, it's the same as each of them to the power of 2 and then divided. And again, numerically, if we had, say we had 3 divided by x all to the power of 2, it's the same as 3 squared divided by x squared, which of course is the same as 3 squared is 9 over x squared.